Okay, is everybody ready? Let's get started. You might have noticed that we have started the computational part of this course, so if you bring your laptop, that would be the most beneficial. I'm not going to go and police that you brought your laptop, but that way you will be the most effective and you will save the work on your laptop. But you are always welcome to work in pairs and borrow or peek over somebody's shoulder. So we have introduced something called module in Python, and that module has a special name. What is that module that we introduced a month ago? NumPy. So it stands for Numerical Python, and it's a collection of the fastest thus far operations on arrays, all kinds of arrays. Okay, and it's a standard by now. Even though Python is open, it's open source, and these standards kind of keep moving, but this is now the most accepted or community accepted module that works with arrays. So numerical Python, and this is going to be the case for every module when a collection of routines, which is what module is, it's a package of special routines, exists, and we want to use it, but it's not part of the standard Python distribution. Okay, so things that come in when you install Python, you will have to import it before you can use it. Otherwise, you're going to get those cryptic messages that the computer doesn't know what it is that you're trying to tell them. Okay? So essential way of importing, and let's open up my Spider, has stayed open where I left it last time. So a note to you is that all of these environments, they will stay open and kind of keep your work open. However, if your computer shuts down for whatever reason, you might lose your work. So the only way to guard against that is to save things in files. So try to have that mental note, and it really goes for anything that you have open on your computer, really. This is not, but when you lose your code and the homework is due, then there can be a lot of frustration because of that. Okay? So if you want to lose your code, then please open up a separate file and save it. Is my file saved? No. Has that little star up there. That's a short for it's not saved. So I have just displayed an unsafe behavior. Granted, I have a backup for this. I have posted for you on Canvas, but still, it's not a good practice to have things unsaved. And if you've been typing things into this command line all that day long, and now you want to save portions of it, you can copy one by one into this file, or you can click on this history log. Okay? And you can basically copy from it. So I can cut, copy, paste just like you can in any other. So these environments for computing are kind of pretty neat that way. And again, I'm exemplifying Spider. Spider is not the only one. It comes with Anaconda, and it has all of the functionality that we need, but it's not the only functionality. So most commonly, you will have ability to edit a new set of commands that you can then collectively execute by having a little run button up there. This is the run button. Okay, so I can execute everything that I have in here, including my import command. Okay, so import NumPy as NP is telling Python that I will use NumPy, okay, and I will refer to it as NP. And then any command that I'm using, and one of the most common ones is just defining an array, np.array. It starts with np dot. And these are, we're going to have a separate topic called functions, but this is using a function that is kind of built into this NumPy. Okay, let's do something with it. So I think by now, so just a brief, I'm going to do a brief review using my slides. So if I want to define my slides, there we go. Always confused about the order here. Sorry, I have to revert things on the... No. I think I have to go and navigate. I don't see the same on my... No. I will have to use it this way right now because I don't see the same thing on my computer. So basically, I have to import NumPy as NP, and to define an array, in this case, example is 25, 28, 1, and 2, so I have 4 elements in this array. I have defined a one-dimensional array C. And Python couldn't care less whether this is row or column. If it's one dimension, it doesn't have row versus column dimension. Now I can operate with that, so whatever numerical thing you want to do with it, or whatever math function you want to do with it, you can. Here's a simple transformation of this. So I can multiply every element of C. All of them will be processed at the same time, which is pretty powerful if there's 1,000 of them. Times 9 divided by 5. And when I do plus 32, what happens when I do plus 30 in this operation plus 32? There we go. So again, this is a nice shortcut. Mathematically, it doesn't stand because this is a scalar and this is a vector. So vector plus scalar, I would not be able to do. Okay? But Python and a lot of computing environments have this shortcut simply to shortcut any kind of coding. Okay? And if I want to refer to elements, they start with 0. This is going to be a little bit of pain because in all of the linear algebra so far that we've learned, we operated with vectors and matrices whose columns and rows started from 1. Okay, so but it's really just a shift by 0. And there's a little cool trick to get the last element, that's C of minus 1. Okay. All right. Now let's do an exercise. Let's see whether you understand what I just said, and let's put it to work for computing scalar product of 2 vectors. Okay. So first, define 2 vectors u and v in NumPy or using NumPy functions. One of them is minus 2, 1, and 3, and the other one is 3, 1, 2. Let's define them. And I'm not going to be typing this time. I'm going to give you some space to do it yourself. If you don't have a computer, peek to your neighbor's computer. Say hi first. My name is, and so forth. Common niceties. There we go. Introduce yourselves. Don't work alone. For our social skills, it would be actually better to have one computer for 2 students. Engineers always need a little help with social skills. Okay? And I'm going to introduce 2 functions that are useful. And if I just gave this an assignment, you wouldn't know necessarily about these functions. But let me give you a tip. If it's a common function, especially mathematically common function, it's out there already. Somebody has programmed it already and put it in some module. Okay? And if I'm telling you that this NumPy is the great module accepted by the community to manipulate arrays, well, it certainly has a norm function in it. Okay? Not only norm, but L1 norm, L infinity norm, L2 norm, whatever norm you might want. Okay? So even if I don't tell you, hey, here is this command, Google it, or whatever search you use, because Google is the dominant type to search, but it's not the only way. Open your browser and search for, type in whatever you need. Python command, NumPy, norm. Okay? And see what comes up. to save you the time, I'm telling you this. And then there is also dot. It comes from dot product or scalar product. And the fact that I'm giving it brackets, curved brackets, signifies that those are defined functions. And inside those brackets, you have to give it input. So if it's a norm is of one vector, it's kind of expected to have at least one input, but it could have multiple. And for dot product, you need two things. So you will need to give u comma v. Whenever we have a function that operates with multiple inputs, you're going to separate them with comma. And the first definition that we had for the cosine between, so let's compute a cosine between these two vectors. Or a cosine of the angle between these two vectors. The first definition that used those rows and columns is not necessarily useful for Python because Python doesn't recognize rows and columns. So I don't need to transpose a 1D array because there's nothing to transpose. So we're just going to use this one. This is a dot product between two vectors. As long as they have the same number of elements, this formula will work. And you can use NP dot. And this is a 2 norm and 2 norm. Is math important? Math is math. It's just called math. But a cosine might exist on the other side. This is another thing. There might be 7 or 8 different a cosine functions. Just a warning. So this is also going to be, so please work on this. This is going to be our first quiz, and my friend Mingyu up there will create quiz on Canvas. So I will expect you to submit this little code by tonight at 11, yes? So how are you going to save them? Great. How did you do So that's your result. Next one. in to help a little. But I'm not going to work on this problem because this problem I want you to solely do and finish tonight. I'm just going to work with whatever I have C here. 1, 2, 3, 4, 5. Or E. E is 3 to 1. Great. So if I wanted to work with norm, okay, NP linalg dot norm of E, okay, I get a number out, and I could also do print of that if it's not coming up on your environment. Sometimes it's finicky. This is something, if I want to work with it, I might want to save that result into a variable. Or whatever it is that I compute with it, right? So cosine theta is NP dot of E, and I'm going to save it itself. Why not? So I'm computing something else because I want you to work on a separate problem independently. And if I want to divide by it, I can. So I'm going to copy this. So you can do with this you can work with the output of this function as a number, and you can further put it into an algebraic expression, whatever it is that you want to do with it. Okay? So you're going to keep adding or stacking things up. Now the question comes up here. We've introduced at least 3 norms, but actually more, because there's P. There could be any. So how do I do some other norm? Okay? And obviously, I don't know, I didn't, let's actually see whether this appears to be the norm 2, okay? But I don't know that for a fact. Well, don't be scared of pulling up a piece of paper and checking what the software does. Because obviously there is some default behavior that is programmed in. So let's see, what would be my 2 norm of E, okay? I would take square root, but let's just work with E of 0 times E of 0 plus E of 1 times E of 1 plus E of 2 times E of 2. Doesn't matter. I will. I can just type it in right now. But yes, it's a good idea to put it as a variable.
We're putting the math as a variable or
norm E. Okay? So now I can print norm E, or I can check out what's happening with it here. And just by looking at it, square root of 14 is approximately 3.7 because 4 squared is 16, right? Now, square root sounds like a function that should be programmed in, right? Okay. How do we find out? Now, if I don't tell you what is square root, how are you going to find out? I want to enable you to find it yourself. Google or whatever, search. So let's search. Square root NumPy. NumPy.sqrt. Great. So NumPy. I already imported NumPy, so I have it. And I call it NP, right? And it's indeed that number. So np.linalg.norm defaults to a 2 norm if I don't say anything. If I wanted to give me a different norm, I can again Google the behavior. You will get a full description of how the function works. But I'm just going to tell you now. np.linalg.norm, I could say E, 1, and that will give me 1 norm. Is it really 6? How do we compute one norm?
I just add the absolute value.
Absolute values of every element and I add them up. 3 plus 2 plus 1 is 6 in my case. Yes? And I could also do infinity norm. Oh, if I can type. But that I would put INF. Oops. It's not infinity? Oh, maybe it just likes INF like this. No? Okay. Quick search. I'm not online. Oh. It should accept infinity. Maybe I need to do NumPy infinity. There we go. Okay. I did start this class with a warning, save your work. Right? Did we figure out how to do that cosine theta? Now that's cosine theta. What is theta? So I need to find our cosine. You should figure out by now that NumPy should obviously have that function. There is multiple other modules that have it. There's a math module that has it as well. So there's no just one answer often, which can sometimes be maddening. Okay? So this is how we do vectors. And again, Ningyu will open up a quiz and I want this problem solved, just the code, and you will save it as .py, a file called .py. You can call it quiz.py or whatever it is that you want. Okay? But the code that computes this, I want posted by 11 tonight. Okay, so we have also introduced last time how to deal with matrices, and we're going to continue with that today. So if I wanted a matrix, basically the way we define them is row by row. Okay? And I would basically say NumPy array, again, this array function. I open up, there's curved brackets because that's how I give input values to any function, is by enclosing them in curved brackets. And then I open up angular brackets, or square brackets. And for every row that I want, I give it another set in angular brackets, and I kind of separate them with commas. It's quite a lot of brackets in there. Okay? And then I can print and work with it. And again, it's an array that I can kind of work with in the entire array. We can print, we can multiply everybody by 5, okay? And if I want to grab a single value from that array, I again start with 0, okay? So in this particular case, where I have array, my row 0 is 11, 12, 13, 14. This A of 0, 0 is this first element. This is column 0, column 1, column 2, column 3. Okay?
So this is element 0, 0 as far as Python is concerned. 0, 1, 0, 2, 0, 3. Yes? My mouse. Ooh, some new behavior here. Well, then I have fingers. This is my element 0, 0, 0, 1, 0, 2, and 0, 3. Okay? In row 1, I have this element 21 is element 1, 0, 1, 1, 1, 2, 1, 3, and 2, 1, 2, 0, 2, 1, 2, 2, 2, 3. Okay? All together, though, I have 3 times 4, 12 elements. Okay? And this is just a review of what we, most of this we did last time, and we're going to continue now. So if I wanted to grab a bunch of elements, I can give a range and put a column in there. So for instance, 0 to 3, okay, those elements are 0, 1, and 2. And that's, to me, personally confusing the way Python does it, but I had no say in it. Okay? So third, this last one is the end point. The end is not included. Start is, but end is not. Okay? And then you can also store you can separate or do a subset of your array in both. I can do subset in both of the rows and column directions. And you can store that if you wish. So this is one way to store you can always store your result to work with it later. Okay? If I omit the first one, 0 is assumed. So you could just write down column 3. And if you just write down column, then it's everybody. Column means everybody. So this way, I'm grabbing or printing my 0th column. Yes, entire column. So again, and it works for any dimension. And then we have some functions, classical functions to transpose. So let's now type in any 2 matrices you'd like. So do I have, I'm going to start with A. So let's define a matrix. Can somebody give me some numbers? 3, 2. So let's do a 2 by 2, why not? One more row? Anyone?
1, 4.
1, 4. Okay? So this is a 2 by 2 matrix. My 0th row. How would I print my 0th row? Zeroth row, entire row, this way. Yes? So all of the elements in row 0. Okay? And the other way around, if I say column 0, that will give me my elements from my first column, but it's not going to display it as a column, because that in itself is one-dimensional array, and all of the one-dimensional array, Python prints as a row. Does everybody see my point? I'm going to repeat. So I have matrix, which is 3, 2, 1, 4. Okay? When I print the first row, I get a row 3, 2 back. But it's really a one-dimensional array, right? When I print the first, or 0, going to be displayed as a row because Python couldn't care less about rows and columns. And it's a one-dimensional object. Okay? You could technically force it to be a matrix. So let's, if I define, I'm talking about C again. Let me do another H. Here's me forcing a column, sort of, by defining a matrix. You see what I did there? Me forcing Python to consider my array as a matrix with only one column. So it's defined, strictly speaking, as a 2-by-1 matrix. Okay? So how do we transpose a matrix? So let me remind myself what my A was. I can say NP transpose of A. So that's going to flip my rows and columns. So remember that 3214 and now it's 3214. Yes. I can also say A transpose. So that's that fun thing with objects being defined as both objects and a set of commands that works on them. So I can actually call that. Apparently I need to print it. This is this, sometimes you have to have this print command and sometimes you don't. Oh, doesn't work now? There we go. So this function transpose, which I have to include these brackets, it works on A, so it takes A as input. And I don't have any other inputs, and it's apparently picky today about specifying it. Shape works the same way. I can do NP shape of A. Or I can treat it as a built-in. And sometimes it wants those brackets and sometimes it doesn't. Give it a try, always.
You didn't have to say print.
Yeah, so in the previous one I had to. Did you notice that? So this is why, like, technically to be safe, always include print. But sometimes I want to short the writing. And it's not always super consistent. This is because there is different groups that have added these modules. It's not always consistent in the behavior. Sometimes you have to have those brackets, sometimes you don't, sometimes print does work, sometimes it doesn't, and it could change from one year to another. So it's an evolving set of rules. All right. And we can do the same for that H. So that you can see that's 2-by-1, whereas my E did not have the second dimension. So remember that H I forced it to be a matrix, and it does have 2 dimensions, and they're 2-by-1. Whereas my one-dimensional array does not have the second dimension.
Submission page up online yet? For submission.
Submission page, no, because NumPy is helping people out. So it'll be right after, sorry. I can also change the shape And shape function does that. Okay? So sometimes I want to make a differently dimensioned array out of the one that I have, out of the same elements. So let's remind ourselves about my A. Okay? So my A has 4 elements. And those 4 elements could technically be arranged in different ways. It can be 2 by 2. It can be 4 by 1 or 1 by 4. Okay? And I could actually force that, okay, by simply changing shape as long as I have enough elements. So I could say A.shape, let it be, when I do equals to, I'm saying let it be 4 by 1. And now when I print A, I suddenly have 4 by 1 matrix. Okay. How did it do it? That's very important. How did it do it? Are you sure? Row by row. So 3, 2 for elements of my first row. Okay. And those were my first ones in this stack of 4 by 1. So it works row by row. Python works row by row. I'm going to repeat that probably a number of times throughout the semester. It's very important because different programming languages have different rules, and there's nothing to say what is the correct way. It's an agreement. Okay? An agreement in Python is to work on things row by row. As a default, it's displaying 1D arrays as rows, even though it doesn't think of them as either rows or columns. It's just how it displays it. Okay? So it goes row by row and just fills out. Now, can I actually do something like this? Okay. No. I shouldn't, right? Let's see what it does. Oh, yeah, no, I can't. Okay? It doesn't have enough elements for that. The reason why I say it shouldn't, mark my words, 5 years from now, it might fill out all of the ones that it's missing with 0. Just to be smart. Or it thinks it's helpful. Okay? So that's, again, a matter of evolving standards sometimes. But most often in these shapes situations, it's best if it doesn't assume something by default, because that can be a source of great errors. Okay? And you not knowing whether it works by columns or rows can be a sort of great errors. Let's just put it this way. Your screen here is a matrix. It's a very large matrix. It's about whatever resolution of the screen is. It's 800 by 1200, give or take. Okay? So it shows as a continuous picture, but it's really a whole series of dots, and each of them has color, and color is a number, 3 numbers actually, that are displayed in this way. Now if I flip this, would you be able to read? If every row of color there is shown as a column instead of, your picture would flip, would you be able to read? So information suddenly becomes garbage. Okay? So flipping rows and columns is important because we interpret the numbers that we see, and those numbers, it's important for us to know where they are and what the position is, sometimes simply to read. Okay? So it can become a scramble if you don't know how the computer operates. All right. So let's multiply matrices. So my A is, I think I changed its shape. I'm going to change the shape back because I need A. So this is a 2 by 2 matrix. Can somebody give me a matrix dimension that I can multiply this matrix with. So I want some B, and I want to be able to do A times B. 2 by 1 works. That's okay, sure. Yeah, let's go. 2 by 1. So whoever said that, can you give me a 2 by 1? Let's try, let's mark it as a vector B. Or one-dimensional array. 2 numbers, please. 4. And 3. Excellent. So let's see, can we do multiplication? There is a function called matmul that's going to do this for me. And the output is 18 and 16. Hopefully correct. At 3, 2, 1, 4. 3, 2, 1, 4. Multiplying 4 and 3. Let's check at least the first of the numbers. It's 3 times 4 plus 2 times 3. Is that indeed 18? 3 times 4? Good luck reading my handwriting. 12 plus 6 is 18. Good. And 1 times 4 times 4 times 4 plus 12 is 16 indeed. Okay, it works as expected. Now let's do a matrix. I'm going to call it uppercase B. Is lowercase b and uppercase B, are those two different things? Yes, they are. Most programming environments recognize uppercase and lowercase as different, which is useful. Okay, so let's now define a matrix. If I define a matrix that is 3 by 2, will I be able to do multiplication A times B?
No.
No. So then how about, what does it have to be? It has to be?
B times A.
So B, if I have a 2 by 2 matrix and I want to do A times B, so my A is 2 by 2, B has to be 2 by something. Okay? So let's do 2 by 3, for instance. So can somebody give me a 2 by 3 matrix? How many elements will I have in the first row? In a 2 by 3? 3. So 3 elements, please. We're gonna, most of our vectors this semester will be 1, 2, 3. And let's do something else than 4 by 6, 4, 5, 6.
3, 2, 1.
Sure. All right, so let's do a multiplication. My result, in terms of dimensions, is correct. It's a 2 by 3. 2 by 2 times 2 by 3 is 2 by 3. And I'm going to be lazy and not verify that the calculation is correct. So, give or take, you have all of the tools you need to do a good portion of your homework number 1 now in Python, and that's going to be the homework assigned today. And the homework will be due next week. However, we're going to do it in a slightly new environment because, do we want to do Spider or Jupyter Notebook for this? Okay, I'm going to say either. So you have learned how to do Spider. I'm just going to now introduce a new tool And why is it cool? It's called Jupyter Notebook. If you go to your Anaconda Navigator, find Jupyter Notebook and click Launch. In my case, a terminal will show up, and actually in that terminal, it will show you everything that it's doing, which you will learn to ignore. Okay? That's a lot. And now Jupyter is running in your web browser, whatever is the default web browser on your computer. Let's check that it works for everyone. And it shows you, this is the sort of root for my files on my computer. So it shows all of those files. And you can navigate to wherever your files are for 310. I'm going to do that right now. Teaching. And then 310. So I have to do quite some navigation. Lectures. And then this semester. And finally, Python scripts. Here we go. I navigated where I needed to be. So it's also browsing your files. And what's cool about Jupyter is that you can do this and you can technically connect to a remote computer and do the same through your browser. That's the cool functionality of it. Second part that is cool, I'm going to open now new one. So I'm going to say new Python 3. So Jupyter Notebook doesn't work just for Python. It can work for multiple other things, but our interest is Python. And now I have a new untitled. So I'm going to say Lecture 2.2 or 2.3 probably, Fall 2019. You can call it whatever you'd like to call it. And now this is actually an immediately sort of a file saved .ipynb. Py for Python, NB for notebook. And notebook files are different from regular Python files. Here's why. I have two options here. One is a regular so-called code cell. This is called a cell. But I also have something called markdown cell. So let me exemplify code cell. I'm going to import NumPy as NP just like I would. And I can define A as 3 and my matrix A as NP array 1, 2, 3, 4. I'm not going to be more inventive than we have been. And then you press enter and it's actually executed. I didn't have any errors, but I didn't print anything. So I can post in that same cell, print A, and then execute it. So that is my code cell. Okay. I can separate my, just give me 1 minute. I can separate my work in multiple cells and kind of execute them independently, which is helpful when you have multiple things lined up. And some of these cells can actually just be nice text. So it's very nice for reports. And most of our homeworks will be done in these because they print nicely into a report like file. So you can pick this time. So either way. But most other homework we will require in Jupyter because it's just nicer file to code, to look at. Huh? Yes, it doesn't have the same variables for, yeah. That's the difference, but it has this functionality of being in a browser so you can go to remote computers.
Fine.